range and domain. The first one, I'm gonna write it like that. D for of y, that's the domain. So here tell me, well, it's the same as we did with 4, but I just want you to write it in the conversation, so I see that you're all still here. Okay. Someone else? Do you agree, disagree? Agree. Good. That's it, right? Well, you either agree or disagree here. Okay, thank you. Thank you. Uh-huh. Mm-hmm. Yes. Yes. So I'm gonna write it with the help of inequalities. So first, for the domain, x has to be greater or equal to than 0. Perfect. I have a question. How do you say it? How does it seem more logical to you? Greater or equal to 0 or greater or equal than 0? Just type 2 or than. Then greater or equal than. Okay. Okay. Perfect. So now I'm gonna use that. Great, so that was, why did I write 0? Yeah, I was supposed to write 5. So we have to make sure that, we have to make sure that what is under the square root is non-negative. Okay, cool. So, two then. Well, let's stick to then because I had more of then. So for the domain we have x greater or equal than 5, and for the range here I'll have y greater or equal than 0. Okay, perfect. That was the first, and to plot it, here is the plot. Now something that is helpful while plotting. So you could see here, if you plotted dot by dot, it's okay. If you didn't plot it, it's also okay. So here you see that it's a normal square root, so it has exactly the same shape as I showed here. Where? Here. So it goes the same, it just starts not with 0 but with 5. So that's a little trick for plotting. If you have your function and within your function you have minus some minus constant or plus constant, it will move left or right. So in case you have minus constant, your graph, it will stay the same shape, it will just move to the right. Given we had plus 5 here, we would move to the left. Let's prove it to ourselves. So here we can plot plus. Dun, dun, dun. Here, so we started at a point minus 5 and the shape is still the same. What else can happen? We can take a normal square root, so we can plot just square root of x and then add 1. So if I want to plot this thing, so say plot y equals square root. There is in the fridge. square root of x plus 1. Plus 1. So kind of like outside like that. In this case, if you have an idea, please type it also in the conversation. Where will the graph go? Let's say. It will move up to 1. Perfect. So you know that. Great. I can plot or not plot. Yeah, perfect. It moved to 1. And in this case, you understand that the range will be from 1 to plus infinite. The range, everything that y can be. Okay, perfect. So you know these little tricks of how to plot without even doing dot by dot. Okay, all agree, cool. Okay, so let's go ahead and prove it. For example, we want and also solve the plotting. The plotting, technically, we know that it should switch to the left one. Let's see. E to the power of x plus 1. Yeah, so our y should be positive, so not just non-negative but positive. Y cannot be 0 in this case. And our x can be whatever. And if, well, here you cannot see very well that it's actually moved to the left, but if you compare the graph to where is my exponent? Well, here I can have it from here. So here it would pass through 1, through 0, 1. And in our example with plus 1, it would pass through here, minus 1, 1. Okay, cool. So x is anything, and y strictly positive. Okay, cool. Let's finish real quick. For the last one, what can you tell me about domain and range? Yeah, no boundaries. It can be anything and everything. To plot this, what we can do is, well, we know the shape, right? We know that it goes like this because it's like, you know, like I showed, because it's cube. We could try to do plots, because you can see where we have zeros, for example. Given x is equal to 0, you know the value of y. Then we can create a product and see where y equals 0, put dot, 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 and put some shape that looks like cube. Or we just do this beautiful thing again. Cube minus 4x. And we get something like this. So this, and this dot are easy to calculate. And then you just put something like looking like cube. If you have to plot it. Well, if you have to plot it exact, software is the best way to do it. If you have to plot it just like a scheme, you have to put the intersections with the axis and then just some shape that reminds cube. Okay, perfect. So I'm not gonna, well, yeah, I'm gonna write it. So we have everything here. The previous whiteboard I already downloaded. So x anything, and y anything. sorry, y anything. Perfect. Now find an inverse of the function. So what will be the answer? Perfect. So great. Why is there no inverse? Well, we just plotted it and we see that it is not the one-to-one mapping. So for one y we have 1, 2, 3 sometimes options of x. So we cannot find an inverse. Okay. Perfect. So that was that was simple. Now I give you another 5 minutes to find an inverse of the demand and find an image and draw the graph. Oh, I hope I can draw it in here. Because otherwise... You should have a lot of questions about it. How do I draw its graph if it is 2 variables? Am I supposed to do 3D? Well, yeah, I let you think of it. Oh, sorry. Okay, so let's check. Find an inverse of the demand function. Again, I encourage you to use the conversation. Oh, I'm so sorry. I haven't checked the conversation in a while. Without plotting, can you explain again why there is no inverse? Well, without plotting, it's hard to explain because you have to actually check all options and all the dots and make sure that there is no y that has two x's corresponding to it. So the best will be just do it with the plotting. Even in the well, let's say definition, what we say is that a function can have an inverse only if it is a one-to-one mapping. So we need to see the map and make sure that it is one-to-one. It's just a matter of knowing the shape of x squared or x cubed. Yes, if you know the shape, it greatly helps you because you understand that, well, if it is a parabola, that certainly it's not one-to-one because you know how parabola looks like. If it is a cube, that most likely it's also not one-to-one because it is like that. Given, for example, well, it's easier to actually say for which functions the inverse exists because for example, you know the exponent graph, well, that's certainly one-to-one, so it will have inverse. And well, I think that the best way, and you will for sure be able to do that, just plot or plot graphically, not exactly like every point exact, but just graphically. I like well, it's explanation too, yeah. But I think plotting straight is good. That's how I do it. Oh, so many messages. Wait a second. Elisa, do we change the variables in the end or not for the inverse? We can or not. It just depends on if we need it for ourselves. No, we don't have to. We just keep it the way we want it to be. If for some reason we are asked to write it correctly, you can, but that will not be the case. So you don't have to change variables. Okay, the inverse of the quantity depending on the price is the price depending on the quantity. Yeah, that's precisely the thing. I didn't get very much the question of with p equals blah blah blah, then it's just the solving of the term for p, but no change of variable. I mean, it's expressing of p in terms of q. And with the okay, not so sure if I understand correctly Elisa's question when p equals 150 minus p over 3. Like, it's already an inverse what you wrote. In general here, okay, cool. Here, since we talk economics, yeah, the easiest would be just to go ahead and express p in terms of q, and you'd get something like 50 minus, and let's write it as a fraction, q over 3. Okay, perfect. So this is price in terms of quantity, and certainly sometimes it's much better to use this form of the function. So you see now quantity in terms of price is an inverse of price in terms of quantity. That's actually one of the inverses that you will use a lot. And here, this helps you to plot it better because, as I mentioned, in economics we mark axis different, so independent goes not where dependent goes in math. So if you find an inverse, it will help you to plot it easier. Other than that, it will help you to see elasticity, sometimes faster, and show the steps, of finding an inverse. Like, what do I mean by expressing P in terms of Q? Okay, so initially we started with Q equals 150 minus 3P. Okay, so now I want to have P on the left side and the Q on the right side. So I want to just extract P. So first of all, I just move 3P to the left and I get 150 minus Q. Okay, and this is just, I move this to the left and Q to the right. Where is my conversation? Sorry. I keep losing it because I have too many screens. Okay, how you would write with Q to the power of minus 1? I will. Okay, just a second. Let's first find the expression. Moved the 3P to the left, change the sign. Moved Q to the right, change the sign. Now we just have to divide both sides by 3 and we'll get pure P, right? Minus Q over 3. Well, minus this. And 50. Yeah, so since it was 3P, we had to divide both 150 and Q by 3. So that's, double. That's what we got. So here we got an expression of price in terms of quantity. That's what we got. Then if we wanted to write it mathematically with the notation of minus 1. First of all, to do that, we'd have to start with function of P equals 150 minus 3P. And then we'd do something like f to the power of minus 1 of P is equal to 50 minus this part that I'm gonna call P over 3. It doesn't make any sense economically because why do we still have P? But it makes sense mathematically if what we were talking about here were mere variables, just letters that don't mean anything. So both answers, this, let's do, let's do green for this one and let's do green for this one. They're both correct. The first one is making more sense economically. The second is correct mathematically. Okay, cool. So that's it. We finished with that. And then find an image by the function. So just give me the number for the image. It's 6. Okay. More agrees, disagrees? Okay, let's do another test of if you're all here. Put plus if you don't understand how 6 appeared. Because you either agree, so you got 6, or disagree, then you got something else, or you don't know how to get it. Okay, I have 1 plus. What about the rest? Okay, great. So, an image of values 3 and 2. First of all, we have to understand that 3 will go for x and 2 will go for y, just because that's how it always is when we give a coordinate of a dot, of a point on a graph. First we indicate x, then y. So that means that now we take an example, because this is an example that I gave you, 3 and 2. X equals 3, y equals 2. Then the minimum of 2x plus 1 and 3y will be equal to the minimum of 2 values. So now I have to just substitute x by 3 and y by 2. So in here I put 3, I get 2 times 3, 6 plus 1, 7. And in here I get 3 times y is now 2, 6. Okay, perfect. So the minimum between 7 and 6, which one do we choose? Well, we choose 6 because that's the smallest number out of 2. So that's how the minimum works. Now draw its graph. I'm terrified because I don't know how to draw graphs here. Let's check if this thing can do it. I mean, I know how to explain it to you, like where do the dots come from. Wait a second, I have one more conversation. L-shaped curve with king points along 2 plus x. Yeah, that's true. Let's try and see if we can. Oh, we can. 2x plus 1, 3y. Okay, no, the other one was better here. Alright, great. So this is how it's going to look, and how it's going to look will be this. So there will be many angles. So what the first question that you were supposed to ask me is, how do I plot it in two-dimensional space if I already have two variables and then I also have f, so the value of the function? Doesn't make any sense. So if you ask me that, all confused, I was supposed to answer you, well, let's just imagine that we fix certain values for x, we fix certain values for our function, because this is what we're trying to plot right now, will be indifference curves. So this will be utility function, and what we're gonna plot are indifferent curves, and this will be your first TD in micro. So, oh, I actually think I'm gonna spend more time than I wanted here. One more message in the conversation. Yes, good question. Was 3 2 point? Were 3 2 points? Yes. I have to give you 2 because the function is of 2 variables. Usually I'm saying find an image of 3 by the function y is equal to 3x. So then you just substitute x by 3 and then you get your answer. In here I was supposed to give you 2 points obviously because the function is of 2 variables. If I just gave you 3, you would be like, okay, this is a value of x or y or both. So that's why there were 2. And better and clearer would be just say find a corresponding value of y if x is equal to 3, y is equal to 2. It's absolutely, it's saying that is saying the same as find an image of 11. Okay, I agree with all of you. But, well, for the plotting, that's another, absolutely another thing. But for just the image, yes, we take 3 because it's first as x and 2 because it's second as y. And that you will do for sure. Like, find a value of the utility if we consume 2 coffees and 1 croissant. Okay, perfect. So now let's figure what is going on when we plot it. So we understand, well, no, we don't understand anything yet. So we start with, so we cannot plot it in 2-dimensional space if everything is changing, right? So if x takes some value, y takes some value, and then f takes some value, well, it's gonna be a mess. We need 3 dimensions. So we're gonna say, let's assume that we fix some value for f, okay? So first graph will be, because for each value of f there will be a certain combinations of x and y. So we're gonna plot it in the scale x and y, and okay, you know what I'm gonna do? I'm gonna actually plot it maybe even in my notebook because otherwise it's gonna take too much time. I'm not so advanced in LaTeX and graphs. So for now I'm gonna explain the logic and then I'm gonna provide a graph for you with maybe more explanations. So the logic, first of all, of how to plot something that is 3-dimensional is we have to fix something. So fix f at the level of, well, 3, okay? Let's fix it at the level of 3, because here it makes sense. You have to fix it at 3, 6, and 9, that's what I did. Okay, fix f at the level of 3. That means what? That means 3 will be the minimum of 2 values, right? Okay. So 2x plus 1 will be 1, and 3y will be another one. So great. What we have to do here, well, yeah, what we have to understand is that for 2x plus 1, okay, given it equals 3, then x will be equal to, I'm taking 3 here and I'm saying given it's equal to 3 just because right now I'm fixing f at 3. And I'm saying, okay, so x is gonna be equal to 1 here, correct? Well, correct. And y is gonna be equal to 1 as well. Okay, that's nice, that's cool. So we know that the minimum in this case will be 1 for x and 1 for y. So now let's see. If x, just consider these two. So if x is taking greater values, so this for sure will be always greater and greater than 3. Thus, 1 is the smallest value for x to fit this condition, fit this assumption, right? Okay, 1 is the smallest value for x, 1 is the smallest value for y. And if we increase both of them, then the level will increase. So that means this is the starting point. Okay, starting point, what? Just think of it as a starting point, as a minimum for x and y to stay at the level of 3. Okay, so we are at this minimum to stay at the level of 3. Perfect. Now, if I only increase x, so imagine that I also fixed y at 1, and I only increase x. So I take x equaling, I don't know, 3. That is, I'm saying y equals 1, x equals 3, then f equals to what? This is the same exercise as before. Just find me the minimum. And type it, yeah. 3. It will still be 3. Why? Because y is equal to 1. And we have to choose the minimum of 3. And here what we'll have 7 again. So that means that I can move x as much as I want, but given y is equal to 1, the level of f will always be equal to 3. And the same applies to the other way around. So if I keep x equal 1 and move y, make it 100, it's not gonna help much because the level of f will still be 3. And that is what is expressed by this weird graph. So imagine we fixed, so let's put ourselves to the positive quadrant, so we are more like starting from here. Okay, so this is what is happening. Let's take the first, well, this one, okay? Let's take this graph. So here what we say is that, okay, no matter how I increase my, in this case, y, let's say that y-axis is y, I can increase my y as much as we want, but we'll still stay at the point, at this point, fixed by x. So for certain x, we can increase y as much, and the same logic applies here. Okay, so we can increase x as much as we want, but we're gonna start anyways from this point. So this is a fixed point for a certain level of f. Okay, so this curve corresponds to a certain level of f. This corner corresponds to something. In our case, we took 3. So then you can fix the level of 6, fix the level of 9, fix all the other levels. And after all, you're going to understand that the shape is like that, right? Yeah, like that as a corner. If you don't see it right now, I would really love to show it with proper whiteboard. So if you really don't like what I'm saying and it sounds nonsense, then we could do it again when we see each other next Tuesday, exactly in a week. And for those who are not in Paris in a week and you still don't like it and don't understand, you can send me an email and we can just do one Zoom devoted especially to specifically to plotting. Okay, so cool. What I was saying is that because we can increase one as much, other being fixed, the value of the function stays the same. It comes to our corner. And then how do we know this line? So we see that there are going to be a bunch of corners. Okay, cool, perfect. But where do we always have this point of the start, like the origin for each corner? That point will be at 2x plus 1 equals 3y. So why is that? Because that means we fix level of f. So here we said we fix it at 3, so we said this has to be equal to 3, and this has to be equal to 3. The same will apply to 6, 9, blah, blah, blah. So these two expressions should be equal to one another. And what do we get from here? We get actually a normal linear, well, dependence, right? So if we want to express y in terms of x, we'll write something like fraction 2 over 3 x plus 1 over 3. So that will be the equation of this line. Okay, we put an equation, all good, perfect, we're happy. Then we just put as many corners as we want. So here they are put with an interval, with a certain interval. I could draw one more here, one more here, one more here. So this is going to be a picture of indifference curves for the utility function that is minimum. Okay, and what else can be very important here? If you don't understand and will not understand after more explanations, well, if you ask me, I provide, just remember one thing. You have a minimum function, you have some stuff inside. It can be whatever. You just do the equation, say, well, x part equals y part. You express y in terms of x to just plot the, it's going to be always increasing, given we talk about utility. You plot that, and then you just plot perfect 90, that's like this for you, 90 degrees squares. 90 degrees corners. Dun, 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 dun. That is how you memorize how to plot that. And you have to plot it for sure, because sometimes you need to solve optimization problems graphically, and that's what you'll have to do.